This video has been created to show you some advanced reporting that we've been able to do over the top of work submitted jobs, or the UBE processing history out of JD Edwards. We've been able to extract the data one of two ways and feed that data into Google's Data Studio for some really nice dashboarding, reporting and drill downs on how performance is actually going across the JD Edwards batch window. We use this information at Fusion 5 to get a 360-degree view of a client's performance and how they're impacted by certain changes in their environments. So you've probably heard that we have a complete interactive view where we use ERP Analytics, or we plug Google Analytics into JD Edwards, and we have similar reporting off the top of this. In this video I just want to show you some of the great things we're doing with batch analysis. As I said, we have two ways of feeding our dashboards with batch reporting information. Firstly, you can use our connector, which uses an AIS server, a public-facing AIS server, and then Data Studio is able to authenticate to and do data requests out of your JD Edwards instance and feed these reports directly through the AIS server. So that's option one. Option two is executing a script that we can give you, which will create a cube of information, and with that cube of information we'll be able to generate reports like this. So what you see here is the initial view of a cube of data that I've created. We're able to choose a date range. This is a global date range. So if I choose an auto date range, I could say this quarter, last week. I've got a whole heap of options here, for example, of what ranges I want to select. But I might say this week starts Monday, or maybe last week starts Sunday. We'll apply that. And so that's going to give us only the batch jobs that have run between the 25th of November and the 1st of December. And we can see that that has reduced what we see here. Now that filter has been applied across all of these pie charts and all of these run times, okay? And so we can see that the jobs that are taking the most or processing the most amount of rows are here in red, and they're not taking a long time to process, but they're certainly processing a lot of rows. So that's processing on average 4.6 million rows of data, once again 4.6 million, and the R2301 is processing 5 million rows of data. And in terms of time taken, the R09814 has taken the most amount of seconds, and that's 146,000 seconds. We can see another view of these jobs in terms of which jobs have been taking the most amount of time with our pie chart here, and we can see the number of jobs in terms of pure execution count, where the most jobs are, and we can see that the R1310Z11 is run 15,000 times in this short reporting period. So that's a considerable amount of time for a short reporting period. So what we're able to do then is start using our filtering, and this is saying based on runtime. So we're getting the same list here as you get here. So based on runtime, let's just narrow down to only a few of these jobs. So these might be the ones that I'm interested in. So I'll just check a few jobs here. And as I said, these are global, so across all pages that I'm going to show you. We're now only reporting on 5 individual batch jobs. We can see those 5 individual batch jobs took 18,000 cumulative seconds over this date range, and they've processed 420,000 rows of data. And all of our other reports are just based upon that as well. So what we'll do is we'll go to the next page of our report, which we've called a job focus. So we're actually focusing on the actual jobs. Remember that we're only looking at these 5 selected jobs at the moment. We can see that in general they run in queue batch, but they've also been running queue single and queue cam long. So they're running in 3 different queues, and only the scheduled user is running all of these jobs. So that's quite interesting. In terms of the total runtime in seconds per day, we look over the last 5 days, which is what the date range we've got selected here, and on the 26th was the slowest day. So the cumulative impact of those 5 jobs and however many executions of those 5 jobs was 13,000 seconds, which is quite a lot of time. And then we get to see how many rows were processed as all. So although 13,000 seconds, it's processed considerably less rows than the 25th, which processed 1.8 million rows. One really cool feature we've been able to create out of this is if you scroll down and look for one of these jobs, if there was an exceptional value in the runtime, and we can sort here by the runtime of each of these jobs, and so if there was an exceptional value here, 48,000, we can click on that and it takes us directly to JD Edwards, where we don't have a token at the moment, but if we sign in, it takes us to the submitted job execution detail screen, and then we get a lot more details about that job. So we can see that it processed for 13 hours. We can look at the processing options. It doesn't have processing options. It didn't have data selection, sequencing, or nor report interconnect, and we don't see the main SQL statement, so that's not going to help us too much. But we can close that down. If we looked at maybe one of the other jobs that's being reported on, it's just doing the 1300s in the beginning. So we'll look at one of these custom jobs. Again, we can drill down to this. We'll sign in. You don't have to sign in every time. So, and then if we look at the audit data, we saw that ran for 32 minutes. And again, we're not seeing a lot of info. It's a subsystem job. Okay. So that's how we drill down directly from Data Studio back into JD Edwards. We'll check one more job, show you that we don't have to log in, and that's all loaded up. We've got the correct job information here. Again, ran for 35 minutes, and unfortunately not a lot of information on this job either. Okay. And if we wanted to look, if we wanted to further divide, if we only wanted to report on particular users running that job, if we wanted to look at how long cumulative in terms of seconds those jobs ran for, or what queue, we can choose to only look at the queue, the ones that launched in queue batch, and then we get a different view of exactly what's going on. So we can slice and dice this data based upon all of these filters at the front. If we go across to our next page, we can see this is a time focus page. Again, our global filters are still applied, and what we can see is a runtime versus number of rows processed. So we can see that it took 30,000 seconds for it to run. It's been run 8 times, and over that time it's processed 433,000 rows. And so we can see the size of the dot is the how many times the job's been run, and then because we're only reporting on 5 jobs, we've only got 5 dots, but you can see how it's context sensitive in terms of the information that we can build. The final report, which is a user focused, and this is really based upon the jobs that we've selected and the users, and some user information of those jobs. Once again, we can see rows processed, and we can see the runtime in seconds for those particular jobs, and the only user, of course, we see is the scheduler user here that's run all of those jobs, so we don't have any other indications there. If we were to go ahead and select all jobs, we get totally different information in terms of all of the jobs and where the time has been taken for those jobs, and of course the usernames that have been executing those jobs. We can see them here. So that's just another way of you getting a holistic view of your batch performance. That can be on a job by job basis, a total time executed basis, number of jobs run, etc., etc. And all of these dashboards and forms are extremely easy to edit with the Data Studio product from Google. Thanks very much for listening. Bye.